we're continuing on our Unit 5 Day 2 notes. We are solving systems of equations using the method of elimination today. So when we are using elimination, what we're trying to do is eliminate one of the variables by combining our two equations in the system. And then once we've eliminated one of the variables, we can solve for the other. Okay, so the previous video, for most of our problems, it was pretty obvious that we were going to either add or subtract one equation from the other and eliminate one of the variables. But what happens when you look at your two equations and you have them all lined up like you want them to be, and there is not an obvious set of numbers that you can add or subtract to eliminate one of the variables? So, for example, x plus 3y equals 6 and 2x minus 7y equals -1. I can't add or subtract right like these are right now to get rid of one of the variables. So I have to manipulate one of the equations or both of the equations. So what I'm going to do is I'm going to try to create an opposite pair. All right, so it looks like x is the one I want to deal with. 1x I get to multiply by any number I want to make it be opposite to positive 2x here. So I'm going to multiply this whole upper equation by -2. Every term in the upper equation by -2. And here's what's going to happen. -2x and then minus 6y equals -12. So it's the same equation, or it's an equivalent equation, I just made it look different. I'm going to just move my second equation over and make sure everything's lined up properly. And by multiplying everything on the top by -2, you can see that now I'm going to be able to add these two equations together and eliminate the x's. Okay, so -2x and 2x, poof, they're gone. I have -13y, and this all equals -13. Okay, you can multiply or divide your equations by anything as long as you're being fair and you're multiplying every single term by the same number. I'm going to solve this. I'm going to divide each side by -13, and I know y equals 1. Once I know that y equals 1, I'm going to go back to one of my original equations. Always go to the original. Don't use the ones that you have manipulated just in case you made an error. Y equals 1, so I'm going to say x plus 3 times 1 equals 6. I'm just substituting that y right back into one of the equations. So x plus 3 equals 6, that means x must equal 3. So I have my x and I have my y, so my ordered pair is going to be 3, 1, and that is my answer. Okay, so let's look at this next problem, number 2. I have 3x minus y equals 14, and I have 5x plus 4y equals 12. So at first glance, they're all lined up properly, and I don't have any opposite coefficients, so I'm going to change that. I have 3x minus y equals 14. I'm going to deal with this y that either has a 1 or a -1 as the coefficient, and I want it to be an opposite to the other y. So I'm going to multiply this whole thing. Think about what you would multiply it by. We multiply it by positive 4. What this does is 4 times 3x is 12x. 4 times -y is -4y, and that all equals 4 times 4 is 16, carry the 1, 56. Okay, then I'm just going to move this equation over. I'm not even changing this one. It's 5x plus 4y equals 12, and I get to combine my two equations. 12x and 5x is 17x, -4y and positive 4y is 0, and this all equals 68. So my x equals 4. Once I know what x is, I'm going to plug it back into one of the equations. So I'm going to choose the top one, but it doesn't matter. You can choose either one. Plugged in my x equals 4, and so I know 12 minus y equals 14, -y equals 2, and y equals -2. I have an x now, and I have a y, so my ordered pair is going to be 4, -2. All right, so take a look at number 3. Okay, and remember, you're allowed to multiply or divide every single term by the same number. So I see 3x plus y equals 2, and I have 6x plus 2y equals 4. They're lined up properly, but I don't have any opposites for the coefficients. But I notice that my second equation, each one of these terms could be divided by 2. If I divide by 2, I'm going to have 3x here. So I can do that, or actually, I'm going to divide everything by -2 because 6 divided by -2 is -3. So I'm just thinking through what can I do so that I have opposites. So if I divide by -2, my second equation is now going to be -3x minus y equals -2. Okay, and I'm just going to move my top equation right over. I don't even change the top one. Okay, so it is a little bit of kind of guess and check in your head. You're just trying to come up with the best strategies so that you can have opposite numbers over here. Okay, I'm going to say 3x minus 3x is 0. Y minus y is 0. So I have 0, that's a number, I have 0 on my left side. 2 minus 2 is 0. Well, that is always true, right? 0 is always true. So this means that for all real numbers, any number that I put in for x, any number combination that works for one of these lines as x, y, it's also going to work for the other line. And if I had divided this second equation by +2, watch what would have happened. So if I had divided the second equation by +2, I would have had 3x plus y equals 2. And note, that's the same exact equation. So I could have even seen that they were the same equation, and I know that that's the same line, and so it's all real numbers. That's my solution, infinite solutions. Okay, looking at problem number 4 here. I have 2x equals 4y plus 18, and I have -5x minus 6y equals 3. First of all, they're not lined up quite right because my equal sign is not vertically in the same place. Also, I can see my upper equation, I'm going to want to divide that by 2. Since these numbers, these coefficients are not perfectly matched up anyway, I'm going to divide my whole upper equation by 2, and I'm going to rearrange it. I'm going to do this in 2 steps just so you can see what's happening, okay? First, I have 2x minus 4y equals 18. All I did was I subtracted 4y from each side. And now I'm going to divide everybody by 2. So I have x minus 2y equals 9. Okay. My other equation is -5x minus 6y equals 3. I want to either get rid of the x's or I want to get rid of the y's. So I can multiply by +5 up here, and then I would get rid of my x's, right? Or I can multiply by +3, and then I would get rid of my y's. Either way is fine. So whichever one you see that you want to work with is totally fine. I'm going to multiply by +5. I'm going to multiply my whole upper equation by +5. So I get 5x minus 10y equals 45. And then I'm just going to bring this guy over as is. -5x minus 6y equals 3. 5x minus 5x is 0. -10y and -6y is -16y. And that all equals 48. So I know y equals -3. Once I know that y equals -3, I'm going to plug it back into, again, one of the original equations, just in case I did my quick math wrong over here. So I'm going to say 2x equals 4 times -3 plus 18. It was 4y, and I know my y is -3. 2x equals -12 plus 18. 2x equals 6, so x equals 3. Okay, so I know my ordered pair is going to be 3, -3. Okay, and so we're going to look at our last problem here. 2x plus 4y equals 6, and 3x equals 12 minus 6y. I need to rearrange so that they are lined up properly, and also I've got some dividing to do. So I'm going to go ahead and divide my first equation by 2's. So I have x plus 2y equals 3. My bottom equation, I'm going to divide everybody by 3. And so I have x equals 4 minus 2y. I'm still not lined up quite right, so I'm going to carry that first equation over here to the right. And now I'm going to rearrange this. I'm going to add 2y to each side, so I have x plus 2y equals 4. When I either add or subtract them, in this case I'm going to subtract the whole bottom line. I'm going to subtract every single term that's vertically aligned, okay? So x minus x is 0. 2y minus 2y is still 0. 3 minus 4 is negative 1. Sorry about that. This is never, ever, ever true, so there is no solution. Okay, if I had wanted to do this in two steps, I would have said x plus 2y equals 3 and negative x minus 2y equals negative 4, if that makes you feel more comfortable. All right, so just have a quick look here at our last page. You're going to try your classwork, but I want you to take a look. Number 1, your answer should be 5.2. Number 2, your answer should be negative 2.7. So after you do the work, you can come back to the video, and if you didn't get the right answer, just double check. And you can see the steps that I chose. You might have chosen different steps. Number 3, I have negative 1, 1. And number 4, I have 7, negative 3. For number 5, I ended up with negative 1, 7. And for number 6, I ended up with negative 4, negative 3. Finally, over here, number 7, our answer was negative 2, 5. And on number 8, the answer was 7, negative 5. So feel free to look back and pause the video if you need to see steps that I chose, and you might have done something different, and that's fine, and you may email if you have questions. Great, thanks.